In section 3.2, we're using parallel lines and transversals. We're taking the angle pairs we looked at in section 1. We're going to take into account now that the lines are parallel and look at the behavior that occurs. So our first postulate is the corresponding angles postulate, which says if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. Before we get into that, this is going to be the common theme for this section. Every hypothesis for the postulates in the following three theorems are going to start with the same thing. We have parallel lines cut by a transversal. Last section in 3.1 where we just identified the angle pairs, these were not parallel. Now they are, and we see that the characteristics that occur with the angles. So it says if we have parallel lines, or if parallel lines exist, then the measure of corresponding angles are equal. 2 and 6 are going to be the same. Their measures are equal. Now, if I had these angles, they'd also be the same. Bottom right, those corresponding angles would be the same. Bottom left, those corresponding angles would be the same. So we actually have 4 pairs of corresponding angles that are congruent. Okay, let's go to our next theorem, which is the alternate interior angles theorem. Starts off the same way. If two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. So that's angle 1 and angle 2. So I'm given that P is parallel to Q. I need to prove 1 is congruent to 2. I'm going to write this proof out. I'm just going to write it as a flow chart. If you want to write it as a T-chart, you can list them out. This would be our first step. I want to get to angle 1 congruent to angle 2. That's actually going to be our fourth step we get here. So again, you can always list them out as needed. But if P is parallel to Q, I want to get to this. Now I can't say because they're alternate interior angles they're congruent. That's what I'm trying to prove. So we have to use what we already know to bring into that proof. Well, what we already know, we just talked about. Corresponding angles are congruent. We look at our diagram. We have angle 1 is congruent to angle 3 because they are corresponding angles. Okay, now, those are congruent. We get that from being parallel. I want 1 and 2. I have 1 and 3. If I look at my diagram again, I actually have another congruence there. That's angle 2 is congruent to angle 3. If we think back, the reason for that is their vertical angles. So now 1 is congruent to 3, 2 is congruent to 3. I want 1 is congruent to 2. So the question is, do we have enough? But if we notice, angle 3 is in both of them. 1 is congruent to 3, 2 is congruent to 3. That means they are congruent to each other. That is our transitive property. So this was step 2, then step 3, and finally step 4. So we use that corresponding angles to get with combined with vertical angles to get us to that transitive property, giving us congruence for alternate interior angles. Now, alternate exterior angles will actually work the same idea. Now, they're different because they're on outside the two parallel lines, but cut by a transversal, our alternate exterior angles are congruent as well. That proof for this one follows the same order as our last one. We start with our given, then from there we have corresponding angles. That's angle 1 is congruent to angle 3. Then we can take into account that 2 and 3 are vertical. And since 1 is congruent to 3 and 2 is congruent to 3, 1 is congruent to 2 by transitive property. So in actuality, all three of these angles would be the same. Notably, 1 and 2 are congruent angles, are alternate exterior. Now, our last one here is consecutive interior. This one is different. Two parallel lines are cut by a transversal, then the pairs of consecutive interior angles are supplementary, not congruent. That is an important one. We do not want to lump those in with the other ones saying that they are congruent. Consecutive interior angles are supplementary. So we're saying that these two angles, 1 and 2, will add to 180. Now, let's walk through that proof and see how we're going to get there. So I'm given that n is parallel to p. That's my given. I know that angle 1 is congruent to angle 3. And the reason is they're alternate interior angles. Now, because they're alternate interior angles and they're congruent, more the fact that since they're congruent, I can say that their measures are equal. And that's by our definition of congruence. So let's just jump from congruent to equal. Now, what we also have here, and this we got from parallel, but what we also have here is that 2 and 3 are a linear pair. And that we just look at from the diagram. 2 and 3, they're adjacent. Their non-adjacent sides form a straight line. They're what we call a linear pair. So that's the definition of a linear pair. Now, when it's a linear pair, we know that the measure of angle 2 plus the measure of angle 3 equals 180. And that is actually by our linear pair postulate. So, kind of ran out of space here, or ran out of momentum here. Measure of angle 1 equals the measure of angle 3. And then I have that angle 2 plus angle 3 equals 180. Where I want to get to is 1 and 2 are supplementary. So, I want to get to 1 and 2 are supplementary. Now I know if they're supplementary that the measure of angle 1 plus the measure of angle 2 equals 180. And that is kind of taking a step backwards, but maybe that gives us a guide. So right now I have 2 and 3 are 180, but I want 1 and 2. Well, wait a minute. 1 and 3 are the same, so if I could replace this with angle 1, I would have this. So, if I took that equal, and that supplementary, or that linear pair, by substitution, I get that they add to 180. And then, since they add to 180, I know that they're supplementary by the definition of supplementary angles. So it's more the fact that these are the same, and these are supplementary. Lets me replace the 1 and 3, they're essentially interchangeable, to know that these two will be supplementary. Now, let's, before we go into the examples, kind of look at what we've done so far. If I took a piece of graph paper and drew two parallel lines, and I labeled some angles. And then I took a piece of patty paper apologies for that, I had to get some patty paper. And I'm going to trace this patty paper so that I have a copy of the angles. So I'm going to copy angle 1, make 3 dots, angle 1, and I'm going to copy angle 2 separately from it. Now I have them copied on this patty paper, and I'm going to take these and move these around and see if I notice something here. Taking angle 1, if I took angle 1 and spun it around, it would match up to angle 3. Now why is that? Well, that's vertical angles. That's kind of something we already knew. If I was to take angle 1, though, and slide it down, I see it matches up to angle 5. Now, why would 1 match up with 5? Well, that was actually corresponding angles. Go by corresponding angles. I know 1 is congruent to 5. If I spin that around, 1 is also congruent to 7. Now, the reason for that, well, 1 and 7 happen to be alternate exterior angles. Now, corresponding and alternate exterior, we talked about already, were congruent, so that fits. Let's see. 3 is congruent to 1. 5 is congruent to 1. By transitive property, I also have angle 3 is congruent to angle 5, which would be alternate interior angles, which we could check. Are they the same? That matches. And that matches. So those would be the same. So really, I have 1, 3, 5, 7 are all congruent to each other. Essentially, all of the odd numbered angles in this case. Now realize you could have a different problem labeled differently, but these are all the same. Now, when I state how they're the same, I can use my different reasons. Vertical, corresponding, alternate exterior, vertical, alternate interior, corresponding. But each one will match up. Those would all be the same values. To take it a step further, let's say this was 60 degrees. I knew that all of these others would also be 60 degrees. Now, see if the same thing works for angle 2. 2's there. It matches with 4. That's vertical. So that fits. Let's see down here. 2 matches with 6. 2 and 6 are corresponding. And then if I spin it around and look at 8, 2 and 8 are alternate exterior. Now, same thing I did with transitive before. I could also say 4 and 6 are congruent, and that's by alternate interior angles. Let's mark these. We'll do double lines for these. So now I have actually all of the even angles also match up, and if I go through and pick 2 at a time, I can name them. Corresponding, vertical, corresponding, alternate interior, alternate exterior, all those match up. So really we start to see in these types of problems, you're really going to have 2 different types of angles. You're going to have the 2 sets. In this case, all the odds that match up, or all the evens that match up. Now let's take it a step further. I said this was 60 degrees earlier. If we know those are all 60 degrees because they're all congruent to each other, we know 2, 4, 6, and 8 are all congruent to each other, so they will have the same measurement. The measurement they will all have is the supplement of the odd numbers. So, I know all of those are 120, and I could go through and find the variety of reasons. Now, if we did this again, and we changed this angle, or we shifted this line so it was a different angle coming in, the same pattern exists. This is what we're working with here. The numbers change, but the idea that these sets of angles are together, these sets of angles are together, remains constant. That doesn't change. This is the big generalization of it, and we go to specific cases, identifying the specific examples from it. Now, the one we haven't talked about, consecutive interior. 3 and 6 are consecutive interior. We look, they're supplementary, so that fits. We'll make a note of that. But let's make another generalization. That's an odd, and that's an even angle. Single line, double line. We know those don't match up. So that clue, if they don't match up in this case, if they're not the same, that leaves it, so they're probably going to be supplementary. And we can see they're not the same angle. One is actually obtuse, one is acute here. And that'll typically be the case, unless they're both 90 degrees. But we can get the hint that these angles don't match up. I could even move it. I know angle 3 matched here, so this is this angle. It doesn't fit down to the other one, so I know it doesn't fit. I know that must be. If they're not congruent, they're going to be supplementary. So as you go through, and if you're having trouble memorizing the pairs, you can at least start to see and solve for the problems when you at least know the values. So let's work through and see. So angle 1 is 114. I need to find angle 5. 1 and 5 corresponding, also 114. Those are corresponding angles. Angle 3 is 68. I need to find angle 6. 3 and 6 are alternate interior angles. So that means it is 68 degrees. Same thing. 7 is 64. Angle 2. Look at those two. I have alternate exterior angles. If this is 64, so is that one. 64 degrees. Then we go to angle 6 is 120. We want angle 4. Now wait a minute. Those angles aren't the same. This is 120. This would be 60 degrees because they're supplementary, because they're corresponding interior angles. Now if you're looking at it saying, well wait, they're odds and evens, how are they the same? Realize, I warned you, numbers change. The numbering of these angles and the numberings of the ones I did earlier are different. So it's understanding the general pattern to it is the key, and you can help you solve the problems. Okay, let's go a step further. I'm looking in the top left here first. I have 134 is this angle. If that's 134, 2 is alternate exterior to it, so I know that's the same. So that one's 134. Then I need angle 1. Well, angle 1 is next to it, so it's going to be a supplement. So 180 minus 134 gives me 46 degrees. Now, if we went a step further and we filled everything in, we know all those angles already, when in fact we just need to know one. We know all of them. Okay, moving down to the left here, I have 79. I need to find 1 and 2. Well, 2 and 79 are next to each other, so that's a supplement. So I can do 180 minus 79 and get 101. And then I have two ways to get angle 1. 79 and 1 are alternate interior angles. And I could just do it 79, or you could say 1 and 2 are consecutive interior and subtract 101 from 180, and it works the same way. Okay, we add a little bit more to it. I have these two angles here, 110 and 5x plus 15. They're in the same location. That means they're going to be corresponding. So I'm going to say 110 equals 5x plus 15. I can subtract 15 from both sides and get 95 equals 5x. So x is 19. Now I look at y. What am I going to pair y up with? Well, it's right next to the 110. That means it's a linear pair with the 110. So y minus 28 plus 110 equals 180. If I subtract 110 from 180, I get 70. And if I add 28 to 70, I get 98. So we can add difficulty to these problems, but it still remains the same thing. Pair up the ones that are equal, make the ones supplementary that are linear or next to each other or consecutive interior, like we've talked about. Okay, two more kind of different examples, ones to be aware of. Top one, I now have 3 parallel lines, but I just go through the same process doing 2 at a time. 133. Well, not real direct way to find angle 1 with 133. So let's actually look at angle 2 first. So looking at just these two lines, the bottom two, if that's 133, angle 2 is also 133 because it's alternate interior angle. Now, that's 133. I need angle 3. Well, angle 3 is next to it. It's a linear pair, So 180 minus 133 is 47, and that's a linear pair to angle 2. Okay, now we need angle 1. We have a couple different ways we could get there. I think the easiest way is to say it's 47 degrees because it's alternate interior to angle 3. Now, if all else fails, you could always go through and fill in every single value and work your way up through the diagram, and eventually you arrive at all of your answers. But it's identifying those angle pairs which is key. Okay, our last one here, we need to find x and y. I'm going to break this one into two parts. I'm just going to look at this left-hand side of it. I'm going to take that and I'm actually going to redraw it. So I have, by extending lines out, this is 3x and this is 60. So I've extended these lines and kind of cut off the rest. If I look at just that alone, I see that those are corresponding. So 3x equals 60 because corresponding or equal, so x is 20. Now we look at the right side, okay, cover that up. That's just the part I'm focusing on. If I redraw that, I get 5y minus 5 and 135. What type of angles are those? Those are consecutive interior angles, so I get that they are supplementary. So 5y plus 130 equals 180. 5y equals 50, so y is